Okay, hi guys. So in this lecture, we'll be discussing on the decomposition of H2O2. So let's get started. So first, let's see the reaction of the decomposition. So we have H2O2 aqueous decomposing into H2OL plus half O2G. So let's say the initial concentration of H2O2 was A, and the concentration after time t would be, let's say, A minus X here. So reaction progresses in terms of volume of KMnO4 when we actually titrate this H2O2 with acidic solution of KMnO4. So this is acidic solution of KMnO4 and this is H2O2 aqueous. So we have already seen that normality is molarity into n factor. So at equivalence point, what we can say, we can say that molar equivalent or milli equivalent rather of H2O2 would be equals to milli equivalent of KMnO4. Okay, so milli equivalent would be N1 into V1. V1 is in ml, would be equals to N2 into V2, or simple, we know, if we know the normality of KMnO4, it would be N into V0. V0 is the volume which is required till the point of volume of KMnO4 which is required till the equivalence point. So herein we can see that normality can be written as molarity into n factor of KMnO4. So the n factor of KMnO4 would be 5 because Mn from plus 7 state would be going into Mn into plus 2 state, so n factor would be 5 into V0. Similarly, normality here can be written as molarity, initial molarity was A, and n factor would be, let's say, n factor of H2O2 would be 2, and volume of H2O2 required was, it's a finite quantity and we are writing it as something like K. So we can see that A would be proportional to V0. More the volume is required for the titration, more was the initial concentration of H2O2. So after time t, what we can write? So after time t, this was the initial mixture. Now this H2O2 actually decomposes itself into H2OL plus half O2. So after time t, less concentration of H2O2 would be present in the aqueous solution of H2O2. So we can write after time t, A minus X times again 2 into some volume K would be equals to molarity of KMnO4 into n factor times, let's say, Vt volume was required at this point of time. So we can write A minus X is actually proportional to Vt, okay, or Vt. Okay, so let's suppose it has been given in the question that the decomposition of H2O2 is a first order reaction, is first order. So we can write K would be equals to 1 upon T ln A upon A minus X. So this can be easily written as K would be equals to 1 upon T ln, what is A? A is nothing but V0, initial or the total initial concentration of initial volume of KMnO4 which was required to titrate the H2O2 solution or titrate with H2O2 solution, and Vt is the volume of KMnO4 required after time t with H2O2 solution, and obviously we know that V0 would be greater than Vt. Okay, so just writing it in words that V naught is the volume of KMnO4 used when reacted with fresh solution of H2O2. Of H2O2, and Vt is the volume of KMnO4 required when reacted with H2O2 solution after time t. Volume of KMnO4 used when reacted with H2O2 solution after time t. Okay, so if we know the V naught and Vt, because, and we will be probably knowing it because how much volume we are titrating of KMnO4 with H2O2, this can be easily measured through this burette. So we can calculate the rate constant with this equation. So with this we come to the end of this lecture. In the next lecture we'll be seeing the reaction progress in terms of volume of oxygen. So till then, good luck and goodbye.